Hello! In these videos we are going to integrate irrational integrals. We are going to work with irrational integrals. Which type? Let's see. We are going to solve one specific type of irrational integrals. It's going to be solved using a change of variables, and what do we need? Okay, some notions of integration and derivatives calculus, and we need also to know how to simplify mathematical expressions, as usual, I guess. Difficulty has increased from the part of derivatives, but okay, let's see if we can deal with this. What type of irrational integrals we are going to work today? Is that integral 1 over a square root of x squared plus bx plus c. You can have an a just in front of x squared, but we can just factor and simplify this part. So I just decided to simplify a little bit the process. Anyway, you can find how to solve it with ax squared plus bx plus c, and it's going to be as easy as this case. Okay, the idea is to use some information about integrals that we have. Remember that we can also we always can have the list of integrals, trivial integrals, called trivial in a wrong way because normally it's not so easy. Okay, but we can have a list of integrals and we apply we can identify some functions and know what is the integral. This is the case. What are we going to do? The idea is that we are going to complete the square for the quadratic expression on inside the square root. This is very easy. It has a formula. You can just obtain step by step the process. You can just think twice or think carefully what are b and c, or how can we write this. But guys, I always remember this formula. It's not so difficult. The idea is the following. Okay, if you have a positive sign here, then the formula is going to be it's going to have this shape. It's something squared. That is the reason we call this process completing squares. Okay, so the idea is to have a something squared, and you need to make sure that this expression gives you exactly this quadratic expression. Okay, so in this case, x squared plus bx plus c. This sign, if this is negative, this sign comes here. Okay, as you can see, in this case it's positive, so I write positive. It's important, okay, about this sign. B, the number you have here is going to be written divided by 2 in this formula. The reason is that the square of this sum is the square of the first element plus 2 times the first times the second. In order to obtain b here, b should be divided by 2. Okay, it's not a really complicated process. It's just to think twice what you are doing. Okay, and also when you just write b divided by 2 here, the square of this expression is x squared plus 2 times the x times b divided by 2 plus the square of the second term. Okay, be careful. Then this number is not here. That is the reason I subtract b squared divided by 4, the square of this number. C is the number it was before, so it's very simple. The idea is when you see something like this, you can write it in this form, completing squares, just by taking this number, dividing by 2, and subtracting this constant square. So it's not difficult. We will see an example. Then, with this expression, with this new expression, the integral can be easily solved using a change of variables, of course. Let's see. This is the example, x squared plus 2x plus 8 in a square root in the denominator. The first thing is we are going to complete the squares here. Okay, so x squared plus 2x plus 8 is, look, x plus 1. Why 1? Because I take this number 2 and I divided this number by 2. So I obtain 1. Then I always need to subtract 1 here. Okay, the square of this number should be subtracted, and 8 remains the same. But 8 minus 1 is 7. Okay, so the completing squares, we obtain this form. Okay, is this form better than the original one? It's the same, but this last form helps us to identify what kind of integral we have. Okay, so we are going to change it in the integral. So we have 1 over the square root of x plus 1 squared plus 7. What is the change we are going to apply to solve this integral? Okay, the change is the following. Everything inside the parentheses is going to be called t, but not t only. This number t, this variable t, should be multiplied by the square root of the number left outside. This is done just to be able to factor later, okay? It's not very intuitive process, but when you see the next step, you understand why, okay? So we got this. If you move plus 1 to the other part, we have that x equals a square root of 7 times t minus 1. It doesn't matter because when we calculate the differential, the derivative of this part with respect to x becomes dx, and the derivative of this part becomes a square root of 7 dt. Okay, so I'm going to change dx by a square root of 7 dt. If you replace in the integral, this square root of 7 has been written outside. It's a constant, let's move it outside. And below, on the denominator, what I just did is to change x plus 1 by a square root of 7 times t. By the way, when you square this expression, the square of the square root of 7 is 7, and t squared is t squared. So that is the reason I just wrote here 7t squared plus 7. Okay, this 7 is the same, and I just apply this change here. So as you can see, I can factor 7 here. So it's what I did, and then I just move this 7, I just separate the 7. So I got the square root of 7 times the square root of t squared plus 1. A square root of 7 and a square root of 7 disappears, and the only thing left is that integral. That integral appears in the list of trivial integrals, and is the argument of hyperbolic sign of t. So if you recognize this is piece of cake. The problem is that if you don't remember what is that, then it's difficult. Guys, I tell you, if you don't remember that this is the argument of hyperbolic sign, then probably you stop here and nothing else, okay? You can apply another change of variables, okay? It can be done, but for sure, if you want to solve this, you need to use hyperbolic functions, okay? We have, probably you have seen an exercise like this, but okay, let's suppose that you have the list of integrals and you know that this is the argument of hyperbolic sign of t, okay? So just plus c, and be careful, we apply a change of variable. We need to undo this change. So the change was x plus 1 equals the square root of 7 times t. If you solve for t, you got this, and you only need to replace t by this expression. Yeah, I know, it's an ugly expression at the end, but the integral is solved, okay? So guys, what have we seen in this exercise? We just solved a specific type of irrational integrals, the one that is 1 over the square root of x squared plus bx plus c, and we practice some properties, mathematical properties when solving this integral. I hope you find this helpful for you, and thank you for your attention.